Welcome, everyone, to our next event as part of the CPO Mastery Series Conference. We are joined here by Rahim Daya, the Head of Product Search at Pinterest. Rahim will be speaking about the importance of product management and AI. Rahim, take it away.
All right, so today I'm going to be talking about product management for AI and how to work with AI systems and build great user experiences for your users. And so to start, I just wanted to introduce myself. My name is Rahim. I've worked in product management for almost 10 years, and before that for 5 years in software engineering. And I've worked across Groupon and LinkedIn and Pinterest in product management roles. A little bit about my background. I did a computer engineering degree at the University of Waterloo, and then I have an MBA and Masters of Engineering from Northwestern University. So today, just to clarify before we start the talk, I wanted to get some terminology out of the way. I've called this product management for AI. That stands for artificial intelligence, but the industry term you'll see a little bit more is machine learning. And then there's a set of terms that you should also know on the types of models there are. So AI is very much a media term. Internally in industry, we use the term machine learning. And then you also hear other types of models, so linear models, logistic regression models, and deep neural networks. Those are all types of machine learning. So this talk actually spans across all of those types of models and can be used on any of those implementations. So today I'm going to be talking about 4 things. Why you should use AI, a little bit about the tech. It's really important, even as a product manager, even if you're not technical, to just understand the basics of how AI works. It's important to understand a little bit about the user experience, and there's nuance to the user experience for AI versus traditional front-end product management. And then finally, some tips to build great AI product experiences. So starting off with why work on AI. So the biggest thing is scale. There's a lot of problems that can't be solved with current technologies. So an example is for Google search, they do roughly 2.4 trillion searches per year. If you were to try to do that with humans or some sort of manual labor, let's say you were to pay humans $10 an hour and you gave them 60 seconds to create a list of results. That would mean Google would require 4.5 million employees, and it would cost $400 billion to operate their search every year. But Google only makes $161 billion in revenue a year, and they only have 100,000 employees. So Google cannot exist without AI. They would not be able to answer all of the questions that they answer in any cost-effective way without the AI systems that allow them to personalize results and find information from the internet. There's also the question of personalization. And so one of the things that traditional media has a very hard time with is providing experiences for people who are not the majority. If you were to look at an image or a spread in Vogue for leather jackets, you can see that they've shown 3 black leather jackets, and that was the style that they were promoting in this magazine spread. But that doesn't cater to everyone. Maybe you don't like black leather jackets, maybe you don't like haute couture style, but instead you like brown leather jackets, you like motorcycle jackets, you want spiky jackets, you like crazy colors on your leather jackets. All of those things are different tastes that people might have, and they're still fashionable, but it's very hard for traditional media to serve that up, and AI systems can personalize to the user that's viewing it. AI is also very good at capturing patterns. So I wanted to start first with a pattern that humans are also good at capturing at, which is visual patterns. And so I'm sure looking at these images, you can identify what each of these pictures is. But you don't have all the information. These are blurry, and normally you shouldn't be able to figure this out, but you can because humans are very good at seeing visual patterns. Well, AI is good at seeing other patterns that maybe humans are not necessarily that good at seeing. So an example is the way Shazam works, and it can create patterns out of music. to identify what different songs have by breaking apart the beats in the song, the vocals in the song, the words said in the song. And so humans have a hard time capturing this. At least it takes us a few seconds to figure this out, but machines can figure this out very quickly. And so capturing those patterns and applying them is what allows AI to do well. And then finally, AI can be used to reduce bias. And so I want to clarify and separate out the types of bias here. So AI doesn't have preferences. And so it allows it to very quickly adapt to the preferences of the user and the information that's coming in. So for example, this is a problem that we have at Pinterest. When you search winter outfits in New York, you probably want something fairly warm. But if you were to search winter outfits in Miami, it's considerably warmer. It's just a little bit cool. So sweaters does the job. And so AI is able to separate that out. Media companies have a much harder time of doing this. And this is why when you go to different parts of the country in the US, or even different parts of the country in Canada, you get different sets of clothing. And sometimes clothing is not very good in the store that you're at, or clothing in the magazine that you're reading is not really applicable to where you live. And so this is why. And so AI does a much better job of this. So rules of thumb on understanding where AI is useful is AI does well when there's lots of data. So there's lots of things that you can observe. And you're actually able to measure behavior and identify patterns. So if that data can't tell you information about what people choosing different things, or there's patterns in the data, it's hard to apply AI. And then the last thing is AI is not something magical. And so with enough money and time, you still need a problem that a human could solve. It's just cost effective to solve it. But AI can't solve things like figure out the stock market or figure out how to make humans live to 1,000 years. That's stuff that still a human would have to figure out first. And then we could use AI to make it better. So let's talk a little bit about the tech behind AI. And it's important to understand just the basics of how the technology works in order to do a good job as an AI product manager. So AI works by taking a set of inputs, processing it through hidden layers, and then getting an output. So the way we train an AI system is we give it a set of inputs with the known right answer outputs, and then it uses that information to train those green circles called the hidden layers. And so the hidden layers are essentially a prediction that allows it to take inputs and get that right output. Later on, when you start using the AI system, you will give it new inputs and it'll make new predictions, so new outputs. And as long as you've trained it effectively, those hidden layers can help identify that. Now, this is actually really hard for a human to understand. So if you were given a model, it'd be hard to understand what is going on in those green circles. But that's okay. You can learn a lot through observation. The second piece is measuring AI. So when you talk to someone about an AI model, you may hear them refer to two different types of measurement: precision and recall. So for example, let's say we're trying to determine if a picture has a couch in it. Precision is when the AI says there's a couch in the picture, how often is it right? So we're trying to figure out prediction accuracy. And so we want something that's right most of the time. The second one is recall. And recall is if there is a couch in the picture, how often do we catch it? And so we want to make sure that if there's 50 pictures of couches in a group of 100 pictures, we capture all 50 that have a couch in it. And so these tend to be trade-offs when you're building an AI model. And so it's important to understand those, because when you're working with engineers, they'll give you these numbers. So if you have a low precision model, so your AI is bad at making guesses, oftentimes you've not provided it enough signal to make a good guess. So either if you're doing, for example, prediction of images, the images are too blurry, or they're low resolution, and so you're not able to identify information. There could also be not enough training data, so not enough inputs and outputs that you've given to the model when it's being trained, or that training data is low quality. There's a lot of mistakes. If you have AI that's low recall, then the AI ignores correct results. Then you might have a set of tricky examples, and you need new signals to be able to identify them. So for example, again, on the picture of a couch, maybe the couch is blending in other materials. Maybe all of the pieces of furniture are the same color, and so it's hard to pick them apart. Or again, there's not enough training data, or there's low quality in the training data, and that can also cause recall problems. Another thing to consider on the technology side for AI is it's important to look at user behavior and not at user feedback. And so an important lesson here is if you were to look at Google from 10 years ago versus today. And so you can see the image from the left is from 2010. The image on the right is from 2020. And there's a drastic difference between how the page looks. But if you were to ask a user, was Google the best search engine in 2010? They would probably say yes. And if you ask them, are they the best search engine today? They would probably still say yes. And so the question is, what has changed? And so users have a very hard time understanding the differences or the changes that occur in recommendation systems. But if you were to look at the performance data, Google didn't spend 10 years with thousands of engineers working on search and not accomplish anything. There's definitely huge changes in the efficiency of that search page. And so if you look at the user behavior, you would see effects that the users wouldn't perceive. So rules of thumb to understand the tech behind AI. AI makes predictions based on input signals and training, and then it provides outputs based on that. The systems are hard for users to perceive, and so you need to look at user behavior, what the user does as a result of the changes. And then you cannot debug AI systems directly. You debug it by putting in inputs and looking at the outputs, the precision and the recall. The way I would think about debugging an AI system is when you try to figure out why a person did something, like pretend you're a detective, you're trying to understand why a crime occurred, you can't actually look into the person's head and find out what happened. You have to look at what they saw, what they heard, and then what actually happened. And AI systems are, in some ways, the same thing. You can't actually look inside the system. You have to look at what the inputs were, what ended up happening, and then work your way backwards from that. So now to the AI user experience. So the important thing to think about from the AI user experience is a lot of product management is conscious product management. And so when I say conscious, I mean that the user is understanding what's happening in the experience in front of them, and they're making decisions based on that. So you're usually asking them to select from a dropdown, press one of two buttons, put check marks and things. You're giving them specific interfaces, and then they're interacting with them. But then there's a set of unconscious things that you might have experienced in products. So one of them that you might be familiar with is what's called dark patterns. So if you were to use the set of buttons on the right, the user would be making a conscious decision between a negative or a neutral or a positive. If you start using different patterns, so for example, highlighting a specific box more boldly than the others, users unconsciously prefer to pick the button that's more prominent. And so that's an unconscious decision that the user is making, not a conscious one. A lot of AI systems are more unconscious. So an example of this in search, this is a search from Pinterest. And so both of these users are searching the same thing, exact same, the word shoes. But you'll notice that the items on the left are all male shoes. The items on the right are all female shoes. And so that's because the user on the right is a male user, the user on the right is a female user. And so this is an example of an unconscious experience change that we're making using AI by using their gender, the user's gender, to tailor the results for them. And so it's important to think about what are the things that I can do based on the information that I have to build a better experience that will give the user what they're looking for without them having to consciously provide that input to me. The next thing is to be opinionated. There are actually lots of correct answers to a question. So for example, if you were to search couch, on the left, you can see what Google will show you, and on the right, you can see the results that Pinterest shows you. And the reason is that Google is very interested in being a transactional engine. So in their opinion, the best thing that you can do when you ask for something is to provide you the thing that you can buy, or the thing that you can go to that is the exact right answer. And so for them, purchasing is very important because they have Google Shopping. And so they will show you literally couches from stores that you can go purchase. On Pinterest, we have a very design-mindedness. And so a lot of people want inspiration on how to design their living rooms. So when you search for couch, we think, okay, how do you design a couch, or how do you complete the look of a couch? So we will show you planned rooms, rooms that are fully decorated, so that you can understand how a couch would look in your house, what accessories you can buy with the couch, what pictures to put behind the couch, all of that information. And so the results are drastically different. And that's a result of, from a product sense, being opinionated on what is the experience that we want to give our users. Finally, it's important to nudge the user to get more information from them, because users will not automatically give you information, and it's fairly annoying to constantly ask them for more information. So you'll see a lot of nudges within the experience. So on Pinterest, for example, we will put suggestions in the search bar that will give you things to search based on what you've searched before. We will give you visual collections that will let you search things that are similar to what other people are searching. And then when you do search for things like toddler activities, they will give you different types of toddlers or different activities that you could be doing with a toddler. And these are all nudges for more information when someone's put something that's fairly vague, so that we can give you a better set of results. So rules of thumb when you're thinking about the user experience for AI, focus on user behavior, not the visual experience. You want to understand what the user will do based on the information that you put in front of them. Have an opinion on outcomes. So what do you want the experience to be for your users, and make sure you tailor your models to deliver that experience. Try to keep things simple, and at each point only have 1 or 2 different outcomes. AI systems can get very complicated very quickly, and so it's important to keep the experience simple. And then get information about the user. So make sure that you're constantly requesting or nudging the user to get feedback and get more context around what the user is interested in. So finally, some suggestions on building great AI product experiences with examples. So if you were to start building a new AI experience, the first thing that I always do when I'm building a new experience is to start with patterns. I try to find correlations within data. So when this happens, the user experience gets better, or the user is more successful, or they're more, they find better outcomes. And then you try to find correlations, causations as a result of that. So the user always does things for a reason, and once you can start to understand what the reason is, you can start to exploit that. An example that we saw at Groupon, when I was working at Groupon, is we realized that sales, for example, in the city of San Francisco was much better than the city of Oakland. And we couldn't really figure out why that was the case. And so we started looking at the data about who was buying it and where the person lives. And we started to realize that cities had very distinct travel patterns. So people from the suburbs or outside of major cities will travel into cities, but usually people inside of cities won't travel outside. And in particular in San Francisco, there's a bridge. There are 2 major bridges that separate different parts of the city. And so bridges tend to be major crossing points where people won't go one direction, but will go the other. Once we realized this, we were able to tailor all of our recommendations. Essentially, people in San Francisco only got deals that were inside San Francisco, but people in Oakland would get deals both in Oakland and in San Francisco because we realized we had good shopping patterns. And that optimization was one of the biggest wins that we did. It drastically increased our email click rates and purchase rates. Once you have a set of patterns that you're interested in, or those correlations, then start to look at examples of how they work and turn those into a measurable metric. So I'll give you an example of, we wanted to make the makeup and beauty experience on Pinterest better by allowing people to find content that better matched who they were. The average user, or the average female user on Pinterest, is someone who is light-skinned, who has blonde hair. And so that's the most predominant result. But we started to realize that there's a lot of people with red hair, brown hair, black hair, different eye color, different face shape. And so all of those things were factors that we were trying to figure out how to build a better experience. So one of the things we did is we went to a makeup store and said, okay, well, how do they do this? And we started to realize that by interacting with a person, a lot of different factors were taken into consideration. And one of the biggest ones was your skin tone. So we decided to see if there was a way that we could extract that as a signal to provide our AI system. And so we turned a set of information, all of the images or all of the colors that we get from a picture on a face, into a set of signals. In this case, it's something called lab color, which aligns actually really well with the makeup industry's way of determining skin tones, and built that into a model that we have that allowed us to train an AI model to identify pictures and categorize them in a set of skin tone buckets. And so that turned into a UI that you can see at the bottom of the screen, which allows you to select your skin tone bucket and then personalize results based on that. So this is very much like walking into a makeup shop, but now we have the signals, we have a way of measuring it, and now we can turn those signals into an AI model that allowed us to personalize results specifically for the user. Finally, once you have a set of signals, you can now develop a model. So you can use those signals to create training data and use that to create a model. And then once you launch the model, make sure that most users are getting a good experience, again, by looking at user behavior and not asking the user. The users won't really perceive those changes. It's important to make sure that you are looking at the behavior of how they're reacting to the changes in the product. Finally, and this is really important, creating target metrics for an AI system, it's important to understand how to measure AI models. So you want to create metrics that are abstract from the model objective. You never want to build AI to directly predict exactly the outcome that you're trying to build. And a big part of that is you get a result called overfitting. And that's probably a detail that you can look into if you're interested. But just suffice it to say, it's not a good way to build a system. So for example, for LinkedIn's job search, our target metric was to get people hired. However, a ranking model would focus on maximizing the employer's job listings, or visits to employers' job listings. And the main reason for that was we couldn't actually measure hires. There's tons of different companies, they all have different systems. We can't actually figure out if someone got hired or not. However, we can see the last point where we hand off to an employer is when someone leaves LinkedIn's search and goes over to the user's website. And so we maximize the amount of traffic that we send to job listings in order to maximize the number of hires. But the gap between the maximizing of employers' job listing visits and getting people hired allows us to also think about qualitative factors that we wouldn't have considered if we were just trying to drive traffic. So we considered factors like, is your user qualified for the job they're applying to? Would they be interested in the company? Are they in the same location as the company? Because those are all qualitative factors that drive hires, but they don't necessarily affect traffic to the employer's job site. If we had just optimized traffic to the employer's job site, then our model would do bad things, like show people jobs at popular companies, because that would drive a lot of clicks, but that probably wouldn't drive a lot of hires. And so making sure that you have a clear true north objective and not the objective that your model is optimizing for is important to make sure you consider factors that the model can't consider. So rules of thumb for building a great AI experience: find patterns in your data and your user research and start to figure out what those correlations are that could be causations. Build signals around those correlations and build training data that captures those patterns. And then work with engineering to develop a model. And then finally, measure progress with a metric that considers both quantitative and qualitative factors. It's okay for the model to optimize just for quantitative factors, but you want to consider qualitative also in how you're measuring the success of it. So with that, I'm happy to take any questions.
Thanks, Rahim. Your points around understanding trade-offs, being opinionated, and understanding the unconscious decisions that AI has are pretty telling. And I think this is something that all product managers are going to have to keep in mind. A question that I have, and it's coming from the audience too, is around, look, we know about the promise of AI when you hear about, how powerful AI can be. And then you look at the results. Pinterest, we can see the results. But if you think about like Tesla as an example, they've been promising full self-driving for quite some time. And there's all this hype around AI is going to change the future. Why is it taking so long to get to things like full self-driving or other, other compelling products?
So the biggest thing that's holding back AI systems is inadequate comprehension of information. So AI systems work very well in simplistic systems, and they don't work very well in varied environments. And one thing that humans are pretty good at handling is what to do in a new situation that they've never encountered before. AI systems do fairly badly on that type of thing. So if you follow AI work on self-driving systems, oftentimes the things that they run into are rare situations. And a self-driving system works really well actually on a highway, where it's a very simple type of environment. Everyone's moving forward. There's no traffic lights. There's no cross traffic. You just are in your lane and you're just moving forward, and you just have to worry about the car in front of you. And that's why when you're on the highway now, you can get these automated cruise control systems that handle your speed, can actually change lanes, do all of those things. Where AI starts to have more problems is like, what if there's no lines on the road? What if I'm in the middle of the Northwest Territories and I'm on an ice road? What happens if a type of animal that the AI has never seen suddenly shows up in the front of the road, like a white moose, and they don't know what to do with a white moose? So those are the situations that they start running into that are very complicated. AI also uses all of the information available. There's an interesting story that I read about self-driving where all of their training was done in Phoenix. But Phoenix has particular colored sunsets. And so during sunset in other areas, let's say London, where it's a lot more foggy, the AI would get confused. And that's because it had been processing information that it had learned during sunset in Phoenix, but that didn't apply elsewhere. Now, a human knows the sun doesn't really matter to your driving, but the AI doesn't know. And so people didn't anticipate that, and they would have to train that out. For more simplistic systems like cruise control on a highway, it's a lot easier, or search results where you're trying to answer very specific types of questions, it becomes a lot easier because it's a constrained system. And the more general you get, the harder it is for AI to perform effectively.
Got it. These are excellent points. Sorry. These are excellent points. And with that, I'd like to conclude the talk. Thank you very much, Rahim, for taking the time to share your knowledge with us today. I'd also like to thank our global audience who've tuned in from around the world to listen to this talk. Please take the opportunity to give Rahim a virtual round of applause, and we'll be back with additional talks later today, so stay tuned. Thanks so much, everyone. Thanks, Rahim.